I welcome you all to one more practical session of the practical broadband communication systems. Today we are going to see the practical, namely establish and test a simple fiber optic link for transmission of digital signal. Earlier we have already performed the similar sort of practical called as establishing a simple fiber optic link for transmission of analog signal. So let's see some facts about the kits again. So this is optical fiber transceiver kit. So we have the initial procedure is same, just we have already performed in earlier practical also. We have 8 switches SW0 to SW7 and corresponding L0 to L7 lamps. So in order to establish the link between transmitter and receiver, we'll connect 1 meter fiber between LED1 and PD1. LED1 is operating at 850 nanometer and PD1 is a photodetector 1 at the receiver side. LED1 forms the transmitter, PD1 forms the receiver. Now after establishing the link, we have already established, so you can refer the earlier video also for how to establish a link between the transmitter and receiver. So now to start with, this is the digital link establishment. So what we are going to do, we are going to generate a TTL signal from this function generator. So a TTL signal corresponds to 10 kilohertz roughly. You can set it up to 20 kilohertz, roughly 10 to 20 kilohertz, any value you can take, and let's say 5 volt. So 10 kilohertz and 5 volt you can take it, or at the most 20 kilohertz so you can take it. So this signal is taken from the function generator and it is given to this IO1, that is input output port 1. As we already seen that this signal available here is internally also available at this particular point. So we have given this with the help of simple patch cord, we have connected this IO1 now. Since we want now digital signal, so we will be giving this digital signal to post, you can see that we can see that this is a post S6, okay, which is called coded data. So this is called Manchester coded data. So the signal is generated from the TTL signal generated for function generator. We are going to give it here, which is called as coded data, Manchester coded data. So it has got two posts. You can see that upper is post B and below is post A. So we are going to connect it this signal from function generator to post B of S6. Yeah, once we connect it, you can see that immediately on CRO. Just I'm removing again. You can check it. I'm connecting now to post B of S6. So immediately you can see that. So this signal is available here. So this is the input, you can say, to channel 1, and this is the coded data, Manchester coded data at the channel 2. So you can observe clearly here that you can see that this is 1. This is 1 0 1 0 1 0 1 0, and with respect to this input Manchester coded data, you can see that with respect to this one, this is 0, with respect to this 0, this is 1. So it is inverted. So we can see that input and input we can see here at channel 1, and the coded data, Manchester coded data available at post B of S6, they are inverted with respect to each other. Right, so this is the encoding part, okay, which is seen at this post B of S6 Manchester coder. Now we have to decode this also. So we have this signal is now internally let's say transmitted. We can see this through transmitter part, and then with the help of optical fiber cable we have connected to that to detector, photodetector 1. So there are two outputs available here, P32 and P31. P32 is without gain and P31 is with gain. So we can connect it this now to P31, which is the output of the receiver, detector output with gain. So now we can give it here to either this point, or now let's see, we have to connect it to post. Okay, it is already available. So this output at P31 is already available. So we'll connect it to IO3 here. Okay, so this is available. This is in fact the same that is available as a coded data. Now we want this to of the form that is decoder output. Now you can see here I have given this receiver output now to decoder section of this OFT trainer kit, sorry, optical fiber transceiver kit. So this is a block, you can see that decoder and clock recovery. So at this post S26 there are again two posts A and B. I am going to connect this decoder output will be available at this post B of S26. So I am connecting here. So you will get a square wave. You can see that So you can see over here the input signal which is available on channel 1, and the output which is decoded signal is available at channel 2. You can see that same 1 is here, 0 is here, 1 is here, again here, 1 is here, 0 is here, 0 is so same signal which was let's say sent TTL signal which is sent as an input signal, it is equivalently decoded at this particular output which is obtained at post B of S26. So this is called decoded output. So whatever is the TTL signal transmitted, it is decoded also at the receiver side. So we have some observations, we already made it. So you can see that. So this is the input that we are given the signal, that is TTL signal around 10K, 5 volt. So this is the input, that is 10 kilohertz 5 volt signal, 101010 like that. So this is the Manchester coded data which is available at post B of S6. This is post B of S6 that we have seen with the help of OFT kit. So this is, you can see that this and these are inverted. This is 1, this is 0, this is 0, this is 1. So this effect we have to observe, that is inverted signal between the input and the Manchester coded data. So once we encode at the receiver side, we have to decode also. So at the output of detector which is obtained at P31 and may be given to post B of S26, which is decoder and recovery block. So you can see that 1 is available here, 1 is again available here, 0 is here, 0 is here. So whatever is the input we have initially encoded, and then now finally we have decoded also. So you can see that it is equivalently received at the decoder output. So this is the same replica of your input with maybe slight change in amplitude. Okay, now this is the second observation which we have to do it in this practical. Now one more last part remain, is called bandwidth calculation for this digital link. So you can see here that this is the output of decoder block which is obtained at point S26 post B. So in order to find the bandwidth we have to simply vary the frequency. Okay, so we can vary the frequency and just try to see what is the effect. Yeah, so once we vary that frequency, this is a square pulse, you can see. This is, we are looking at channel 2. So if I vary the frequency, you can see that the output which is decoded output starts getting distorted. So the frequency at which this particular wave, which is a square wave, completely gets converted into a sine wave. That particular frequency we are interested in. So with respect to decoder output, vary the frequency and measure the frequency at which square wave gets converted into sine wave. So that is called the cutoff frequency for this link. So from this cutoff frequency we can compute bandwidth by the relationship, it is bandwidth is equal to 2 into fc. So in this case, for example, if fc comes out to be let's say 14 kilohertz, the point where the square wave has completely converted into sine wave, so that frequency is 14 kilohertz. So just putting that value of 14 kilohertz, we get the bandwidth around 2 into 14 kilohertz, that is around 28 kilohertz. So this is the bandwidth for the given digital link that we have established between the transmitter and receiver. So this is the observation that we have to do. You can do one more observation also, like which we can see here. Input voltage versus output voltage. So input voltage we have already set around 5 volt and 10K. So you can vary the voltage and see the output at P31 here also, and you can note down these readings just by varying the input voltage and checking the output voltage. So with the help of this amplitude knob, you can also vary the amplitude and check the output. You can see that once we vary the frequency and amplitude, it starts getting change from its basic nature, and we can see that effect of saturation also, where we can convert that sine wave into a typical square wave into a typical sine wave. That effect we already seen, and that is called as a cutoff frequency measurement. So okay, so that is one more part. That's all for this practical, just measurement of bandwidth and measuring the input versus output for the establishment of the digital link. So with this we have completed this practical.